So now the pre-formulation topic. What is meant by pre-formulation? What is meant by pre-formulation means? Pre means before. Formulation means design of dosage form. What are the dosage form means? Tablet, capsule, parenteral and aerosol. So before designing of a drug in the form of tablet to capsule, parenteral and aerosols, we need to know about some physical and chemical properties of a drug. That's why we are doing the pre-formulation studies. These are majorly required for doing the pre-formulation studies in the phase 2 clinical trials. Means in the phase 2 clinical trials we are going to design about that. We are going to design the dosage form. Means in the what form a drug can be formulated, like tablet, capsule, parenteral or aerosol. So what are the physical properties? Physical properties means macroscopic and microscopic. And next, chemical properties. In the physical properties, macroscopic means size of a drug and shape of a drug and color of a drug, like organoleptic properties. And next one is microscopic. In the microscopic, we are characterized by using the microscope, like the physical form of a drug, means whether it is a crystalline or amorphous, like the polymorphism topics we are going to discuss majorly here. And next, four properties and derived properties of a drug. All these properties we are going to design, or we need to know before formulating a drug into the particular dosage form. And next, what are the chemical properties? Oxidation, reduction, hydrolysis, isomerization, racemization. These are the chemical properties. So, if the physical properties of a drug, if a drug having the physical properties, we can alter or we can modify the physical properties of a drug by formulating the drug in either salt form, prodrug form, or polymorphism. In the polymorphism like hydrate, solvent and co-crystals. Next one is crystal. What is meant by crystal means arrangement of atoms or molecules in three-dimensional space. What is the crystal means? Crystal means arrangement of atom or molecule in the three-dimensional space. We are called as a crystal. Then crystal lattice. crystal lattice means the arrangement of either atom or molecules in the crystal itself. So this unit we can call as a unit cell. This one part we can call as a unit cell, and this is another unit cell, this is another unit cell, this is another unit cell. So repeated arrangement of unit cell in the three-dimensional space we can call as a crystal lattice. So what are the lattice point means? These are the lattice points. These are we can call as a lattice point. Next one is crystal. Crystals can be based on internal structure. Crystal is chemical compound. A chemical compound can be based on the So when you consider a crystal, then it is a chemical compound. Initially it is a chemical compound. Then what is the external appearance? The external appearance of a compound can call as a habit. This is we can see visually. With eye we can see this habit of a crystal. Like these are different types. Needle type, acicular, and other extras, and others also there. And in the internal structure, when you consider the internal structure of a crystal like this, Then how the atoms, this is the internal structure. The external structure is just like needle type, acicular type. But when you consider the internal structure of a drug, this is the internal structure. Then it is a crystalline or amorphous. Then it is a crystalline means this kind of arrangement is there. Like in crystalline, the arrangement of atoms is like this. In the amorphous, arrangement of atom is like the holes are there, or space is there. Here no space or less space is there in the crystalline compounds. In the amorphous compound, more space is there. Empty space. This is the empty space. More space is there in amorphous compound. So crystalline compounds, again it is single. Single means just like A, only one component. In the multiple means A plus B, means two components or two molecules are also called as a molecular adducts. Next, under the single non-stoichiometric, sorry, no, not single, stoichiometric, the solvent and hydrates will come in the non-stoichiometric layer, channel and cloth threads. These three will come under the complementation topics we can discuss there, and solvents and hydrates we can discuss here. Next, properties. The properties of polymers. Here, what kind of properties means? The polymers having same physical properties, in gas and liquid state. But when it comes to the solid state, the physical properties varies. See, in the polymers, the same physical properties in the gas and liquid state, but when it comes to the solid state, there is a different physical properties we can observe in the solid state. So what are those physical properties means? Very important, this one. Melting point. Sublimation. Vapor pressure. Hygroscopicity. Deep descent. Stability, solubility. So means See what are the properties of polymers. In the what kind of properties they will differ in the solid state. So number one is melting point, number two is sublimation, vapor pressure we can discuss in the next class, next hygroscopicity, next delicity, stability and solubility. So also this also include electrical and optical properties. So this also include electrical and optical properties of polymers. So we can consider the first thing, melting point. Melting point nothing but just the attraction between two molecules. See, just simply two molecules are there, strong attraction, more melting point. If two molecules are there, weak attractions, then results less melting point. So this melting point is helpful to determine the strength of attraction between the two molecules. If the strong attraction will be there, more melting point will be there. Weak attractions will be there, then less melting point. This melting point is majorly useful for characterization of crystalline for the characterization of crystalline polymers. For the characterization of crystalline polymers. See, whenever the polymer having weak attraction, then less melting point, then it readily soluble in the water. Solubility increases, dissolution increases, bioavailability also increases. See, whenever the weak attractions between the molecules are there, then solubility increases, dissolution increases, followed by bioavailability of a drug also increases. Next one is sublimation. Sublimation nothing but conversion of a compound from a solid to from a solid state to the vapor state, we can call it as sublimation. So in the sublimation point of view, what will happen means,